here is add and subtract. Nice, or not so nice numbers, fractions. We dealt with integers, whole numbers, and natural numbers last time. Before we get to that, we're going to compare rational numbers. We're going to compare numbers in general using those four symbols there on the left. Greater than symbol, less than or equal to, and greater than or equal to. Whoops, that is wrong right there. What did I do wrong? I'll have to go back and fix that. That is definitely not a less than symbol. Fix it in your notes. That is a less than or equal to. Remember, the equal to part is the part that's underneath it, right? You have that little solid line underneath the symbol that would mean equal to. It's the only time you're allowed to say that this number and this number are allowed to be equal. Okay? And so what I have here is we should have understanding that when you see it open, sometimes when we first started learning how to use these symbols, the mouth, we always like to say sometimes it's like an alligator or something, always opens to the larger number. Well, now we're going to start putting variables in there, so it's not very easy sometimes to say that one is definitely bigger than the other number. And what we have is, we're still not, so you need to know the name. So you need to say, okay, I know that I have this written like x is greater than 3. So that means x actually can be 4, 5, 6, 7, 8. It can be 3.1. But what it can't be is 3 or 2 or 0 because it has to be greater than 3. It can't be equal. So kind of sometimes to be able to compare fractions, we sometimes look for common denominators. Remember, a common denominator is the bottom of a fraction. We sometimes look for the least common denominator because it's the smallest numbers that the denominators both go into. And so least common denominator would help us if we need to create a common denominator. So remember, the least common denominator is the smallest denominator both fractions will both go into, I should say. It's the smallest that both denominators, fractions, will go into. So this will allow us then to compare our fractions. So the example 1, we need to put something inside or between the two fractions. It's a little smaller on the screen, but in your note packet you can see that we have 2/3 and 5/6. So what I want to do here is get a common denominator on this problem. The next problem over, we'll switch it using our calculators. Because there's more than one way to do these problems. The whole idea is to figure out which one's bigger. If they are bigger, maybe it's equal to. But we need to fill in the appropriate symbol from above. So, 2/3 and 5/6. What would be a common denominator? Likely, we would like to get the least common denominator between those two fractions. So what number does 3 and 6 both go into? So counting by threes, 3, 6, 9, 12, 15, 18. Count by 6, 6, 12, 18. What was the first number they had in common? 12 can be one of them. That would be a common denominator. That's perfectly fine. They both go into 12. But they also, yes, both go into 6. 6 does not have to change then. 6 can stay 6. But 3 can't stay 3. It would have to be multiplied by what to get to be 6? By 2. And what do you do to the bottom? You have to do to the top of a fraction. So I'm going to multiply the bottom by 2. Very hard to see over there. And what I do to the, here, I'll rewrite it. And what I'm going to do then is I'm going to multiply the bottom by 2. So I multiply the top by 2. Because what I do to the bottom of a fraction, I have to do to the top, otherwise I change it. And so, since I'm not going to change the 5/6, I'm left with now 2 times 2, which is 4 over 2 times 3, 6. Something symbol in there, and 5/6. Which one's bigger, 4/6 or 5/6? Which one would I rather have? We're talking about, I don't know, pieces of candy. Do you want 4 out of the 6 or 5 out of the 6? I want 5. And so 5 out of 6 is bigger than 4 out of 6. And so I would put that symbol. What's that symbol called? What's that called again? It's above. Is that greater than, less than, greater than or equal to, less than or equal to? Which one? Yes, it's a less than symbol. So therefore we have answered the first problem. Getting a common denominator. Happened to be 6 was also what we call the least common denominator. The next one, which I'll make a little bit larger here, is 4/3 and 15/9. I want you to do this one by switching them to decimals. So take your calculators out and switch those to a decimal version. So what we get for 4/3, it ends up being 1.3 repeat. We'll put a box here saying that there's something going to be there. And what is 15 divided by 9? 1.6 repeat. And obviously, which one's bigger? The one on the right, which we use again, a less than symbol, because 1.6 repeat is bigger than 1.3. This is easy to say, hey, my alligator mouth or that symbol is going to be opening to the larger number. Now, I think we talked about this one in another lesson, but we're going to bring it up back here because it's going to have you guys use a number line again. So I think this diagram really kind of highlights the idea of what a number line is. Now remember, the origin of any graph, we always like to call it 0. If it's a 2-variable graph, then we have 0, 0, 3 variables, 0, 0, 0. But 0 is in the middle of the graph. Granted, guys, 0 does not always have to be in the middle because your graph could be moved left or right away from 0 because your numbers might not be there. Remember, as you go in the right direction, your numbers get positive. It's a positive direction. Going to the left is a negative direction. So therefore, negative numbers, positive numbers. We talked about those in the last section or two about what does it mean to be positive or negative. Now again, if I was going to order these, and I think we did talk about these yesterday, the steps here are to switch numbers to decimals. Makes it a lot easier. Plot them on your number line. And then, looking from least to greatest or greatest to least, no matter which way you want to go, I can go left to right and just put them in order. The one thing I didn't put on here for the directions are make sure that you go back and replace them with the original value. So again, if we would have had that 4/3 that we used in the last problem, you would want to write that as 1.3 repeat as a decimal, but when we go to actually use it in our number order, we put 4/3 back. Okay? So, let's try putting that to use. So, here we go. First problem I want you guys to do is order 5 and 2/9, 5 and 3/8, 4.9, and a negative 5 and 3/5. Now look at this. I necessarily wouldn't even have to graph all of these on a number line. Can you guys tell me which one's my smallest number? Just by looking at this, which one's the smallest one? It's the negative 5 one. It's the only negative number, right? There's only one negative. So technically, we know this one's going to be my smallest number. And then you jump all the way to the other side. Well, they have, we don't know because the 5s both have different denominators. So we could probably get common denominators if we really wanted to. We can convert those to decimals, but I would say that 5 something is bigger than 4 something, right? So we already can get the idea that this would be my smallest one, this would be my second smallest at 4.9, and then we'd move over to the 5s. So we could use a number line then, or the decimal idea. So what is 5 and 2/9? Wait a minute, that's a mixed fraction. Are you guys okay with mixed fractions? How do I convert? We'll say 5 and 2/9. Convert that to, say, improper first. How do you convert to improper fractions?
9 times 5.
Right. 9 times 5. I'm going to use the color here. Multiply the whole number times the denominator. So it would be 5 times 9, which equals 45. And then you add the numerator to get 47. And you place it over what?
9.
Over 9, or the denominator that was there. So this is the improper fraction versus the mixed fraction of 5 and 2/9. That necessarily doesn't help us because I can do the exact same thing with 5 and 3/8. They're not common denominators. So maybe let's do the decimal thing. What is 47 divided by 9?
2.
So this is 5.2 repeat. What about the other one, which was 5 and 3/8? We know it's going to be 5 something because it's 5. What's 3 divided by 8?
0.375.
375. So we know that this would be 5.375, and this is 5.2 repeat. So which one's bigger? The 5.3. The next one would be 5.2. We want to go from least to greatest. So my smallest number is the one that is negative. That made it easy. The next one was 4.9 because that's smaller than any of the 5s. And then 5.2. Wait, I don't want to use 5.2. I want to use 5 and 2/9. And the last one is 5 and 3/8 because I want to use the original problems that they gave us. Okay?